Hello everybody. This is lesson 9 of the lecture International Financial Markets. I will discuss the slides 87 to 109 of chapter 2, Major Market Segments and their Assets. In this lesson I will talk about the influence of differences in interest rates on the exchange rate. The purchasing power parity theory shows that goods prices and hence trade with goods affects the exchange rate. However, interest rates and expected returns on capital markets can also display a strong influence on exchange rates. To analyze the relationship between exchange rates and interest rates, we need to understand the difference between the spot and the forward exchange rate. So far, we have used the spot market exchange rate only. On the spot market, a euro today, this means time index T equal to 0, is traded against a dollar today, time index T equal to 0. And the exchange takes also place today. So the purchase agreement between buyer and seller is made today and the exchange takes place today. Everything is done today on the spot, therefore it's called the spot market. Now, on the forward exchange market, a euro at, let's say, 3 days from now is traded against a dollar 3 days from now at an exchange rate that is, however, fixed today for the exchange that takes place 3 days from now. So the purchase agreement, inclusive a fixation of the exchange rate, takes place today. But then the exchange of currencies takes place in the future, at day 3 from now. So agreement to exchange and exchange takes place on 2 different points in time. That is what we call the forward exchange market. Now, given this background information, we can again find the accurate relation between the exchange rate on the spot market and prices for domestic and foreign goods with the help of a numerical experiment. Where would you invest your money at the following exchange and interest rates? The interest rate for a fixed rate bond denominated in euro with a maturity of 1 year is 10% per year. The interest rate of a fixed rate bond denominated in dollar with a maturity of 1 year is 6% per year. We assume here and in the following that both bonds are within the same risk class, for example government bonds. The spot market exchange rate here is given by $1 for 1 euro. The forward market exchange rate for euro against dollar paid in 1 year is $0.92 per euro. To find out whether an investment in a euro bond or whether an investment in a dollar bond is more profitable, we have to calculate the revenue of these investments in the same currency. For an investment in a dollar bond, this is quite simple. Let's assume we invest €1, so after 1 year our return will be €1 times the interest factor. The interest factor is 1 plus the interest rate. If we fill in the euro interest rate of 10%, this yields a revenue of €1.1 after 1 year. So this calculation is quite simple. If we want, however, to invest €1 in a dollar bond, we first must convert this euro into dollar. So here we have to use the spot exchange rate, because this transaction takes place today on the spot market. The resulting amount of dollar can then be invested in the dollar bond at the dollar interest factor. Now we have to take care that we receive at the end of the year a dollar payment as revenue. This is not a euro payment. Therefore, we have to convert this amount of dollar into euro with the help of the forward exchange rate. We know the forward exchange rate 1 year in advance, since it is fixed today. Therefore, we can be sure to repatriate our dollar returns into euro at this forward exchange rate, no matter what the spot exchange rate will be 1 year from now. All we have to do is to agree in a forward contract today, for example, as offered by a commercial bank or on the forward exchange market. Now we can fill in the numbers into this formula, the numbers from our numerical example, which are again given here above. For the spot exchange rate, we fill in $1 per euro. For the dollar interest rate, we fill in the interest factor 0.06, 6%. And for the forward exchange rate, we fill in 0.92 dollar per euro. Then we can calculate the numerical value of the dollar investment. The result is 1.15 euro. This means an investment in the dollar area is more profitable than an investment in the euro area, since the return of a dollar investment is higher than the return in a euro investment, which equals only 1.1 euro instead of 1.15 euro from a dollar investment. Since the return of a dollar bond investment is higher than the return of a euro investment, people want to invest their money only in dollar bonds. As a result, demand for dollar grows. You want to buy dollar bonds, you need dollar. And if demand for dollar grows, we know that this also means that the supply of euro grows. As a result, the euro depreciates against the dollar. This means that a spot exchange rate of $1 per euro cannot be an equilibrium value. Given this relation here, the spot exchange rate cannot be the equilibrium exchange rate. There is still adjustment pressure on the spot exchange rate. Now let's try another example. That again shows a dollar interest rate of 10%, a euro interest rate of 6%, just as before, but a spot market exchange rate now of only $0.9 per euro instead of $1 per euro. So this is now a depreciated value of the euro against the dollar. For simplicity, we take again the same forward exchange rate of $0.92 per euro. Now we have to do the same calculations again, however only with the lower spot exchange rate as a difference. So what we have to do is compare an investment return in a euro bond with the investment return in a dollar bond. The return of the euro bond stays, of course, the same as before, since we do not need to make any exchanges in foreign currencies, so the different spot exchange rate has no influence on the investment return of a euro bond, and this return stays 1.1 euro. However, if we want to make a dollar investment, we have now to use a lower spot exchange rate. The formula is of course the same, only the number is now smaller. It is not 1, it is $0.9 per euro. So this leads to a lower amount of dollars which we receive. So we can invest less money in the dollar bond. The interest rate is again the same, and the forward exchange rate is again also the same. However, given this lower spot exchange rate, the return of our dollar bond investment is lower. It is only 1.04 euro instead of 1.15 euro. So the investment in a euro bond provides a higher return than the investment in a dollar bond. Since the return of a dollar bond investment is lower than the return of a euro bond investment, people want to invest their money only in euro bonds. As a result of this, demand for euro grows, which means that supply of dollar grows. As a result, the euro appreciates against the dollar. This means that at a spot exchange rate of $0.9 per euro, we have not an equilibrium exchange rate. There is still adjustment pressure on the exchange rate, in this case upward adjustment pressure. What is then the equilibrium spot exchange rate between euro and dollar? Well, it must of course lie somewhere in between $1 per euro and $0.9 per euro. since at $1 per euro we had depreciation pressure, and at $0.9 per euro we had appreciation pressure on the euro. So how do we find now the equilibrium exchange rate between euro and dollar? Well, we can of course use the same procedure, the same method that we have already used to find the equilibrium purchasing power parity exchange rate. We take all the other numbers, the interest rates and the forward market exchange rate for given, leave the spot market exchange rate as an unknown variable, and then we force equality between the return in a euro bond and the return in a dollar bond, and solve for the spot market exchange rate, the unknown variable. So let's apply this. We force now equality of both sides of the equation. So the investment return in a euro bond must equal the investment return in a dollar bond. So on one side of the equation we calculate again the return of a euro investment, fill in the numbers, which gives us the value of this investment, which equals 1.1 euro. On the other side of the equation we calculate the investment return in a dollar bond. We exchange our euros into dollar given the unknown spot exchange rate. Then we calculate the dollar return from this investment, and then we exchange this dollar return back into euro with the help of the forward exchange rate. If we fill in the numbers now, we have of course the spot market exchange rate as an unknown variable. Then we must multiply this amount of dollar with the dollar interest factor, then divide the dollar return over the forward exchange rate. And in order to find the value of this unknown variable that equates both type of returns, investment return in a euro bond and investment return in a dollar bond, we have to force equality between both sides of the equation. So let's keep the unknown variable, the spot exchange rate, on the right side of the equation, and let's bring all the other variables on the left side. On the left side we have already the euro interest factor. We divide both sides of the equation by the dollar interest factor. The dollar interest factor disappears on the right side, reappears on the left side. Next we have to multiply both sides of the equation with the forward exchange rate. Then the forward exchange rate disappears on the right side and reappears on the left side. And then we can calculate the value of this expression, which of course equals the equilibrium spot exchange rate. The spot exchange rate, where an investment in a return in a euro bond is equal to an investment of a return in a dollar bond. And this equilibrium exchange rate here equals $0.9547 per euro. So the value of the equilibrium exchange rate is indeed between the interval of $0.9 per euro and $1 per euro. This is the equilibrium exchange rate. At this exchange rate here, euro and dollar bonds have the equal return. Measured in euro or in dollar plays no role. This example demonstrates that An equilibrium on the exchange market can only exist if interest and exchange rate are such that investors are indifferent between investing money at home and on foreign capital markets. This relationship is therefore called interest parity. So in an equilibrium on the spot exchange market, the following equation must the return on an investment of a euro and a dollar bond must equal the return that we receive if we invest this euro in a dollar bond and first exchange this euro for dollar, therefore, then invest this money, it's a dollar amount of money in the dollar bond, and then exchange this dollar return back into euro with the help of the forward exchange rate. This equation and this formula is called the interest parity equation. The interest parity formula shows the potential effect of interest rate changes, for example, on the exchange rate. If the domestic interest rate increases and the foreign interest rate and the forward exchange rate stay constant, the euro appreciates against the dollar to restore the equilibrium of this equation. The economic interpretation of the equation in this case is if domestic interest rate increases and everything else stays constant, euro bonds offer a higher return than dollar bonds. Consequently, investors will want to buy euro bonds and sell dollar bonds. To do so, they have to exchange dollar against euro so that the demand for euro grows and the supply of dollar increases and the euro appreciates finally against the dollar. If the foreign interest rate increases, however, and the domestic interest rate and the forward exchange rate stay constant, the dollar appreciates against the euro, which means the euro depreciates against the dollar in order to restore the equilibrium of this equation. Now the economic interpretation is if the foreign interest rate increases and everything else stays constant, dollar bonds offer a higher return than euro bonds. Consequently, investors will want to buy dollar bonds and sell euro bonds. To do so, they have to exchange euro against dollar so that the demand for dollar grows and the supply of euro increases and the euro finally depreciates against the dollar. The interest parity theory helps us to understand, for example, why the euro typically appreciates against the dollar when the European Central Bank keeps its interest rate constant while the Fed, the American Central Bank, the Federal Reserve of America, lowers its interest rate. Or why the euro depreciates, for example, against the dollar when the US economy displays strong growth, which increases the profits of US firms and hence expected stock dividends. The interest parity theory is an important mechanism that helps us to understand the interrelationships between exchange markets and domestic and foreign capital markets. So the interest parity equation helps us to understand how changes in interest rates affect the spot market exchange rate. But so far our results are completely theoretical. The question is whether this interest parity equation is also empirically reliable. Transaction costs are, of course, less important on capital markets, since, for example, capital international market transactions cause no transportation costs today, because these transactions are typically registered by online booking systems. So no physical transfer of assets is typically necessary. So from this point of view, the interest parity equation should hold better than the purchasing power parity equation. In fact, a lot of empirical tests with regard to these questions have been undertaken. I would like to show the results of a test based on a diagram. This test was undertaken by the German Bundesbank a couple of years ago. To understand this diagram, we have to modify the interest parity equation in the following way. We start with the equation the same form as we have derived it so far. Now we divide both sides of the equation by the euro interest factor. So the euro interest factor disappears here on the left side and reappears on the right side as the denominator of this fraction. Then we divide both sides of the equation by the spot exchange rate and multiply both sides of the equation by the forward exchange rate. And then we receive on the left side of the equation this fraction. Now it's quite simple to check for the validity of the interest parity equation with the help of a diagram, as you will see. This diagram measures the ratio of the exchange rate on the y-axis, so this is the left side of the equation that we have just derived, and on the x-axis we measure the ratio of the interest factors, the right side of the equation which we have just derived. The equation implies, of course, that all observation points lie on this 45-degree line. This 45-degree line is the bisectrix of this 90-degree angle of the diagram. It mirrors all points on the x-axis to the same points on the y-axis. For example, if we start on the y-axis at a value of 1, the 45-degree line reflects the same value on the x-axis. Or if we start on the y-axis at a value of, let's say, 0.996, the 45-degree line reflects the same value on the x-axis. As the blue observation points in this diagram reveal, they lie typically quite close to the 45-degree line. Small deviations can be explained by the existence of comparatively small transaction costs like bank fees and brokerage. Stronger deviations are quite seldom to observe. However, if you take one such outlier, like in this region here, so let's take this one, we can see that here the exchange rate ratio is too high for the given interest factor ratio. Such a situation implies the possibility for a profitable deal without any risk. For example, taking a dollar credit and investing the money in euro bonds where the interest rate is too high for an equilibrium. This will cause the dollar interest rate to grow and the euro interest rate to fall, and the spot exchange rate to appreciate. As a result, these transactions will cause a movement back towards the 45-degree line. Since thousands of investors continuously scan the markets with very fast computers to detect such possibilities for a riskless profit, these type of corrections take place quite fast, such that most observation points actually lie quite close to the 45-degree line. To sum up, this diagram shows that the interest parity equation performs quite good from an empirical point of view. So it is in fact something we can rely on. To close this lesson, let's transfer our considerations on a market diagram for the foreign exchange market. What does the interest parity equation imply for the slope of the euro demand and the euro supply curve on the foreign exchange market? Well, from the perspective of financial markets, supply and demand curves on the foreign exchange market have the normal slopes. The euro demand curve has a negative slope because the cheaper the euro, the cheaper are bonds from the euro area for foreigners, which implies a higher return measured in foreign currency. If Americans want to buy more bonds, however, more euro bonds, however, they have to convert more dollars into euro. So the euro demand increases as the euro gets cheaper or depreciates. The euro supply curve has a positive slope, like supply curves typically have. Because the more expensive the euro is, the more dollars are paid for 1 euro, and hence the cheaper are US bonds for residents of the euro area, measured in euro. This implies higher returns for foreign bonds measured in euro. If Europeans want, however, to buy more American bonds, they have to exchange more euros in dollars. As a result, euro supply increases when the euro becomes more expensive, which means when the euro appreciates. Let's measure the exchange rate again on the y-axis and the volume of traded euros, the transaction volume, on the x-axis. The euro demand curve has, as just considered, the usual negative slope. The more euro is paid for $1, the cheaper euro assets get, so that the return on an investment in euro assets grows. The euro supply curve has the usual positive slope, since the more dollar is paid for 1 euro, the cheaper American assets get, so that the return on investment in American assets grows. The intersection point of both curves provides the equilibrium exchange rate. What happens now to the equilibrium exchange rate if, for example, the euro interest rate grows, such that it is larger as in the initial situation? The interest rate does not appear on the y-axis, hence it is here a shift parameter in this diagram. If the interest rate in the euro area grows, American will try to invest more money in the euro area where they receive higher interest payments. Consequently, the demand curve for euro shifts upward or to the right. Since less Europeans want to invest less money in the USA, because US interest rates are now less attractive as the higher European interest rates, Europeans demand less dollar and hence supply less dollar to the foreign exchange market. Consequently, the euro supply curve shifts to the left. The new intersection point between both new curves lies on a higher level as before, which means that the euro appreciates against the US dollar. This means, of course, that the graphical analysis comes to the same result as the interest parity equation. If the interest rate in the euro area increases, this causes an appreciation of the euro against the dollar. Let me sum up our findings. Trade in goods and trade in financial securities affect the spot exchange market at the same time. Both kinds of trade have the consequence that supply and demand curves on the spot market have the standard slopes, as is well known from microeconomics. The more dollar is paid for 1 euro, the more US goods are cheaper than euro goods, and the more euro is hence supplied in exchange for dollar.